Hi, hello. My name is Gopichan. I am from CSC B section, 5th semester. Today, my tech talk topic in computer network is optimize optimize the data center networks. A study on trusted energy saving transmission methods in computer networks. The introduction. This is the introduction. The data centers are the crucial components of modern computing interfac- infrastructure responsible for hosting the application and service that support everyday operation. The increasing, however, the increasing demand for the com- compositional power and the data storage has led highly heightened energy consumption. These facilities, the study explores trusted energy saving transmission methods in computer networks to optimize the data networks, reduce the energy consumption, and maintain the performance. Importance of the energy efficiency in the data centers. There are some points that are cost reduction, environment impacts, performance optimization. We discuss on cost reduction. Cost reduction, that energy costs represent a significant portion of data center operational expenses. Reducing the energy consumption directly impacts the bottom of the line. And next, environment im- impact. High energy use contributes to carbon emissions. Optimizing energy consumption supports the sustainable goals. Performance of the optimization. This is the next point. And the efficiency energy use can be enhanced overall network performance and the reliability. Current challenges are the high energy costs, heat of the generation, and the network congestion. These issues necessitate innovative approaches to ensure the optimal performance while the reducing the energy usage. We discussed detailedly the energy saving transmission methods that are dynamic voltage of the frequency scaling, energy aware routing protocols, sleep methods of the pro- power management, data commer- conversion techniques, utilize the renewable energy source, loading the balance and traffic shaping, green networking techniques. Discuss detailedly the dynamic voltage of the frequency scaling. The dynamic voltage and frequency scaling adjust the voltage of the frequency of the component based on workload demand, managing power usage of the during low activity provides. The benefits of the dynamic voltage and the frequency scaling is the reducing the energy of the consumption while the maintaining the performance, especially during the variable workloads. And the second points of the transmission method, saving the transmission method, aware the routing protocols. Energy aware routing protocols, implementing routing protocols that consider the energy consumption when the selecting paths can be optimize the transaction. The benefits of the energy aware routing protocol is that minimize the energy using data transmission by the choosing the routes that reduce the power consumption, particularly in multiple hope networks. And third point, sleep modes and the power management. This is nothing but isolate the sleep mode for the ideal devices. Example switch routers allows for significant energy saving without the efficient affecting the performance that are not affect the performance and utilize the sleep modes. The benefits of the sleep modes and power management that reduce the power consumption during the period of the low activity by the putting devices into the low power states. Fourth points of the data corruption. Data corruption. Data corruption before the transmission can be reduced the data amount of the data transferred over the network lead in the overload. This benefit is decrease the bandwidth and requirement energy consumption. And main trusted transmission method is load balancing and the traffic shaping. This is nothing but a disturbing the work workloads evenly across the several prevent energy waste due to the utilize utilization of resources. The benefits of the load balancing and the traffic shaping is nothing but optimize the resource usage and minimize the energy consumption by the ensuring the all components of the efficient utilize. There is another point method is there is a green network techniques. Green network techniques is adopting energy efficient network technologies that are low power modes can be significantly reduce the overall energy. The benefits of the green network technique is the enhance the efficiency of the data center network while supporting existing interface infrastructure. These are we discussed data column in the compression techniques, traffic shaping, load balancing solution, energy monitoring tools, case studies. Future trend of the data center networks will be likely involve the advancement of the AI, machine learning, and the automation. These techniques promise to further optimize energy consumption and enhance the power performance and saving the smarter and more efficient centers. And the challenge and consideration. Challenges considerations the performance trade-off of it and the implementation complexity monitoring the management. Case studies and the results. Case study 1. A data center implementing the dynamic voltage frequency scaling showed the 30% reduction in the energy consumption during the peak hours without the compr- compressing the performance. Case study 2. The adopting the energy aware routing protocols resulted in 20% decrease in the overall network energy use, the demonting significant potential optimizing. Recommendations. The to optimize the data set computer network, The organization should be adopt the combination of the trusted transition methods, invest in the energy monitoring tools, and the continuous evaluate their energy strategies. Overall, the optimized conclusion is that optimizing the data center networks throughout the trusted energy saving transmissions methods presents a valuable valuable approaches to reduce the energy consumption while the maintaining the performance. By adopting the strategies of the energy aware routing, trusted energy saving transmission, and leverage the renewable energy sources, the data centers can be achieved and the significant cost savings and the contribute of the environment sustainability.